See it by now? Here, we'll turn the light on. It's still warming up in the projector, but we are doing 7.3 today, rational exponents. Which is the other important thing, which is also a great thing about graphing calculators. Okay, so rational exponents. Now, so rational exponent really just means our exponent powers are going to be fractions instead of whole numbers. And I'm going to show you how to rewrite them is all we're really going to do, okay? So the first, most basic one we have ever seen is b. B is just an example, to the 1/2 power. Okay? That can be rewritten as the square root of b. So that's how that happens. Because when there's no number here, it's really 2. And isn't that a button on our calculator we can actually use? We can find the square root of things. So if you really see 4 to the 1/2, it's really asking you, hey, what is the square root of 4? Which we shouldn't need a calculator for, right? Because we should all know that that answer is what? What's the square root of 4? 2, right? Saying what squared? Well, you can't see that equal sign because of the light. So you're just saying 4 to square root of 4, 4 to the 1/2 can be written this way. A lot of times with the 1/2 power, they never put the 2 there if you don't remember that, okay? So you won't usually see it. And then you can just solve it if you can. It's really that easy, okay? So here's a couple examples. It says, write each expression in radical form, which is this. That's a radical sign. Or write each as an exponent form. So it depends on what form it's in. So you have to look at what is where. So I have, first one, 25 to the 1/2. How do we rewrite that? I don't like that light today. Okay. How do we rewrite that? Square root of 25. Do we know what that answer is? It is 5. Okay. What's the difference between that one and this one? 5x to the 1/2. What's the difference between those two things? Well, yeah, one has a variable. That 25 is one number, yes? So the whole number 25 is to the 1/2. Is the 5 and the x both to the 1/2? Or is only the x to the 1/2? Just the x is to the 1/2 because there's no parentheses. Only the x has that 1/2. So when we write this, 5 has nothing to it, so you leave 5 alone, and then you write square root of x. That is how you write that answer because the x is the only thing that has the 1/2. And then this guy right here, if I just add a little sign of parentheses, about 8p, close my parentheses, to 1/2, what does that mean? Now this one means the square root of all of it, 8 and p is underneath. You see the difference? So you got to pay attention to what is attached to that 1/2. Okay, now I'm going to go backwards. I'm going to give you the radical form, and you're going to write it as exponent form, okay? We just went exponent to radical. We're going to go backwards now, okay? I'll just erase that too, why not? Okay, we just did 3, so 4. How about 6 square root of x, y? Being tricky now. How would you write this? How would we write this one in exponent form? Does the 6 have anything going on with it? No. So I'm just going to write 6. Then how do I write this in exponent form? parentheses xy, then what? Close them and then put the 1/2 only around those. Did you write this also on your paper? Does that make sense? Okay, I'm going to give you 2 of them. You write them, and then we'll see if you get the answers I get. Okay? These are a little close together. Okay. Hmm. Changing my mind. So look at it, see if you get the same answer. I already wrote mine down. I just freeze the screen so you cannot see it. Do y'all have it finished? We ready to look? Okay, I'm going to unfreeze it. Did you get the same answers as I did? Now, if I put parentheses around the B, would it technically still be right? Yes, but we don't really need parentheses, right, unless there's more than one thing. So did we all get this right? Does that make sense? Okay. Now we're going to talk about when the number's not 2, okay? Okay, so this is called the nth root. Okay? So that means it says if a to the n power equals b, so some equation we have, right? Then this can be rewritten as the nth root, so it's like a square root, but instead of, we don't know what the power is, that's an n, of b equals a. Yeah. Which all it's really saying, so here's a like actual number. So it's saying 2 to the 4th power equals 16, which we know and we can check, right, using our calculator. This also means that we can rewrite this. We can say, hey, the 4th root of 16 does in fact equal 2. No matter which way you say this mathematically, the statement is true. The good thing is you had your calculators, right, so you could use the answer, right? That's the best thing about it. Okay, and I'm going to show you something. So the reason we know this, right, we can guess and check, but if we have some crazy radical and we want to know why this makes this, I'm going to show you. If we had this, 4 through to 16, I'm going to rewrite it for you. You want to say, what makes 16? So you break down this number. You go, okay, what times what makes 16? My first thought is 4 times 4. Anybody else? Is that your first thought too? Right? Okay. Now, when you break these numbers down, the first thing is to always break them down either to squared numbers, which 4 is obviously a squared number, or prime numbers, okay? So I'm just showing you, well, 4, isn't that made from 2 times 2? And another 4, again, that's made from 2 times 2. I have a question for you. How many 2's is that right there? So 4 2's make 16. That's why the answer is 2, because we have a group, we have 4 2's. Our answer is, how many? I need 4 of something to make this number. Well, I have 4 2's. That's why that answer is 2. So that's that math comes from. I have 4 of this to make that, because later what happens is you're going to want to break down radicals, and sometimes they don't work perfectly, but you can simplify them. So you don't have like the square root of 256. You can break it down to be like 5 radical 6, which is way prettier to look at. Okay, so we're just going to practice simplifying these, but the good thing is we can use our calculators. Okay, so I have, first, for example, the 3rd root of 27. So the first part is, do we know or remember, we hope so, how to type this into our calculator? What do we do? What's on there? Do you know what buttons to push? Okay, so if you have a root that's anything other than, I would just say anything other than 2. What you first do is say whatever that number is in that corner, you push it. So 3, then you push math. Do you see when you go down, it should be the 5th one, how it says X root? You click that and it pushes that 3 up into that power spot. And then you just type in your number, 27, and push enter. Does it give you a whole number answer? Yep, what's the answer, Lauren? I got 3. Lauren got 3. Even if the number's ridiculous, like this one, the 4th root of 10,000. Tell me, what's the 4th root of 10,000? That would be nice to know. It's a nice whole number for now. So 4. Do you need help, Cam? Oh, what's the answer, Camry? The answer is 10. So the best part is you can just type her right in there. Okay? So now that you've seen how that works, we can talk about what happens when you have b to 1 over n power. A little note. What is this going to turn into? Do you know? Based on what we did with the 1/2 power, what is that going to turn into? And radical b is correct. So whatever that denominator number is, that's on the outside of the radical every single time, right? So then you can have any number. If it says, hey, what is 8 to the 1/3? And you're super afraid that if you type in fractions into your exponents, you're going to mess it up. You go, okay, I can rewrite this as the cube root of 8. And can I easily type that into my calculator or know it in my head? Because I would have this little secret hope in my mind as your teacher that you would know what that number is. What times itself 3 times makes 8. 2. That is the correct answer. Thank you, Tristan. So now we've seen it's when b 1 over n. Let's look at it when it's not 1 over n. So we're going to erase this and do, I think it's the last, oh, it's not the last note, it's the next last note. We're going to have b to the m over n. This guy can be written 2 different ways. He can equal, the denominator still means a root, so he can do the nth root of b, and then we put parentheses around the whole thing to the m power. Because this, once we take this away into a radical, it's just a power, right? So that's one way. Or it can be the radical of b to the m power. So that m power can be outside or inside of the radical, just depending on what you want or need. Usually it's easier to simplify numbers if it's on the outside like this, because then your number's not so big to try to deal with, okay? So for example, we will do a couple examples. We have 64 to the 2/3. So how are we going to rewrite this? What's my root power going to be? Denominator. 3. I'm going to put 64 underneath. I always do it when the 2's all the way on the outside. So when it's written like this, you deal with the inside first. Can I simplify that number? Sorry. Can you simplify the cube root of 64? Actually, if you type it in correctly, you can type that all into your calculator. 4, and then you square that answer. Cube root of 64, Kimber said is 4. Then you have to do that squared, which means our answer is 16. If you type it in, as long as you know how we wrote the parentheses here in that problem, as long as you write the parentheses and make sure when you put the end parentheses, you're outside the square root, you do it. If not, do them in pieces so you don't mess up. Okay, let's try another one. Let me look for ones with different numbers. 256, ironically I said that number earlier, to the 5/4 power. How about you try that one? Okay? Well, I take a drink of water if I can find my water. I don't know what that noise is, but it's scary. So rewrite it, type her in. I'm gonna write it too while you're not looking, while you can't see what I'm doing. Did you get the same answer as I did? See, that's not so bad, is it? Not at all. Easier than what we were doing. Camera's secretly like, no, I like it. I'm good at it. I like it. Okay. Good, good. Lastly, and then we'll mix them together, we're going to talk about exponential equations. Okay. What this really means is, I'll give you a little definition. I just don't have enough room on my board. It's when variables occur as exponents in equations, obviously. Okay, so let me give you the general example for the equation. So if I say I have an equation, if I have b to the x power equals b to the y power, that's my equation. As long as b is not equal to 1 and b is greater than 0. Those are the two rules. Huh? See, and this is the worst part. That's why I always save this for last. But then that whole remote week just threw us off. Man. The rule is when the bases are the same, you can cancel them out. Since you remember, like what's on one side must be on the other. If you have the same thing on both sides, they can cancel out, and all you're left with is x equals y. And that would be your answer. Did they give you this information then you had to like solve? Or back? It's on the part 2, so if you didn't finish it, you can go back to it. There is a positive to that. Sorry. Okay. Let me show you a real life example because this doesn't make a lot of sense unless you see it. Okay? Okay. We'll do an easy one real quick first and then we'll slowly move on. So basically, 5 to the x equals 5 to the third. That's as basic as I can possibly make it. Right? Since the basis numbers are the same, you can get rid of them and you literally have x equals 3. That's the answer. Okay, we'll make it a little harder. So now, this is where you get bigger numbers. So you have 6 to the x power equals 216. So this is like a normal problem. This is the kind you usually get. Okay, so this kind of problem you go, okay, this number right here is 6. That's a small number, isn't it, in comparison to the fact that it's almost a prime number, right? Nothing squared makes this number, right? So this is as small as this number gets. So we want to make this number the same as that one. So we go, 216, that has to be 6 to some power. So it's really like guessing and checking. You go, I wonder what 6 to what power makes 216. You just take a guess. Well, I know it's not squared. I would just, can't be too small, but can't be too big. I would guess 5 and see how it goes. Well, okay, 6 to the 5th. Type it in my calculator. Ooh, that's 7,000. That is too big, right? So you just guess. Who's going to get the answer first? Me too. So then you go, okay, well, that's 6 to the x equals, and you technically should, if they tell you to show your work, you have to rewrite it. So, well, that's 6 to the third. Then, since my 6's are on both sides, they can cancel out. What does x equal? It equals 3. They give you this so you can do, they'll show you the easy ones, so you can do the solving equation ones. 24, I don't like that one. 25 to the x minus 1 power. So it's got some stuff in it. Equals 5. First off, what does 5 technically have a power of? 1. With these, I would write it, because if not, you will forget. Okay. Now, 5's the smallest number. We can't break it down anymore. So we want to rewrite 25 as 5 to some power. Without even using calculator, we should know what that is, right? This is what? 5 squared, yes? Everything that was already there needs to be brought down. You see how this is in the power spot? See how this was already in the power spot? So you need to bring it down in parentheses because they're in the same spot. They're sharing the same space. Equals 5 to the first. Because something was already there. Then, are your bases the same? Cancel them out. Only write your exponents. So 2 parentheses x minus 1 equals 1. Now you are left with a linear equation. Can you solve this? What do you do first to slowly get x by itself? You can distribute, sure. 2x minus 2 equals 1 now. Plus 2. 2x equals 3. Now what? Divide by 2. You get x equals 3 over 2. Would we have ever been able to guess that fraction as an exponent? That's why we solve it and rewrite it. Does that make sense? We're going to do more. It's okay. And this is what the bottom half of your homework is. Make sure you got it. Or am I good to erase? Everybody? Okay. Okie dokie. Let's try another one. How about 12 to the 2x plus 3 power equals 144. Okay, 12 is a smaller number, so first check and see that big number 144. Can we rewrite it as 12 to some power? Yes, ma'am, we can. Okay, 12 to the 2x plus 3 equals what? 12 squared. Are my bases the same? So now I have a linear equation. Can I easily solve that? Can I? Can we all? Is this much better than trying to read off my notebook? Is the whiteboard better? Okay. Does that make sense? That's not so bad? Okay, well, you know what? Sometimes technology errors are a blessing in disguise, aren't they? And the best thing is, if you got a calculator, right, it helps you a lot. The other thing is, and I did get to show it, it's not on your homework today, but for your test, because I meant to say it yesterday too and losing my mind. So if you have a number that doesn't square root, so let's just pretend it's a square root, so there's a 2 there, right? Let's just give you a number that's obviously not going to work. 106. I just made it up, okay? If it asks you to simplify the radical and leave it in radical form, you break it down. You ask yourself, what times what makes that number? When in doubt, if you don't know on the top of your head, 106 is a terrible number. Okay, 108. Okay. You break this number down, okay? When in doubt, divide it by 2 because it's even, right? So you say, okay, well, this is 2 times 54. Well, 2, that's as broken down as it can ever be, right? Can I break down the number 54? It's even, so I can at least break it down by 2, can't I? So 54 divided by 2 is 2 times 27. Again, can I break down the number 2? Nope. 27 is 27 something. 3 times 9. Yep. Can't break down the number 3. Can I break down the number 9? 3 times 3. This is a perfect number, actually. Okay. What was my root power again? This 2 means every time I have 2 of the same number, it becomes like a whole number. So every time I see it, this is what I do. I go, I have 2 of the same number. I circle them and go, oh, I got a group of 2. So I have 2 more of the same number, at least 2. I need 2 of them. I'm going to make a group of 3s right here, right? Okay, so I have a group of 2, so I write the number 2. I have a group of 3s. This is all multiplication, isn't it? I write a group of 3s. Did I have anything on my ends that I couldn't group? I had this sad guy right here, didn't I? And I always box him differently. Whatever was not at the end of your tree that couldn't be pulled out is left under your radical sign. And that's how you actually simplify radicals, which is the end of this chapter that we'll never get to. Well, we might do. I don't know. So then that 2 times 3, since they were pulled out because they were a group, they were a pair that was pulled out, this is 6 square root 3. Just a little tidbit for later or when you finish your test. Okay, so good luck, and we are done.